In this video, I want to dig into a problem that's landing on every DevOps team that works with AI, which is probably you. And this is not about what an agent can do, but what it should be allowed to do. Because the instant you point an AI agent at a deploy pipeline, it's actually running with someone else's credentials. And usually those are the credentials that can touch everything. And sometimes that could spell disaster for you. So today we'll build a real DevOps deploy agent, give it exactly the access it needs, and watch a fine-grained authorization system make that call live. The agent we'll be using is Goose, and the thing deciding what it can touch is SpiceDB. Let's get started. I'm going to use Goose, an open source AI agent that runs on your machine. It's part of the Agentic AI Foundation, and it talks to tools through an MCP, which is the same protocol that everyone's standardizing on. And I've actually given it just one tool right now, which is a deploy bot. Here's the important bit though. Before this deploy bot does anything, it asks SpiceDB, an open source authorization system, a question, which is this agent allowed to do this right now? In this demo, I have a user named Alice who works in DevOps, and Alice delegates permissions to an AI agent, let's call the agent Goose Alice, to access the staging environment for the next 1 hour. I've preloaded some common commands that you would use when speaking to an agent in a DevOps pipeline. So let's say we want to deploy the checkout flow to staging. You can say this, and Goose checks permissions with SpiceDB. Right now, the agent has access to deploy to staging, and this check is made live against SpiceDB. You can see a check permission that's actually made here. You can also roll back your checkout in staging because this agent has access to staging. Now let's deploy again. Now let's assume that Alice wants to speak to this AI agent to deploy to prod. Currently, this deploy bot does not have access to prod. So let's see what happens. Goose checks with SpiceDB, and you can see it needs approval because this deploy bot does not have permissions to speak to prod. And in this case, you can actually use a human in the loop or a manual intervention and give the agent access to prod. And I've assumed 10 minutes here. So you can see for the next 10 minutes, this agent has access to the production server, and I'm going to deploy checkout to production again. There you go, deploy, and it's now, you can see this agent holds the delegated deploy on the environment production. And again, all of this is being checked live with SpiceDB right now. Now, here's the cool part of the demo. I'm going to revoke staging permissions for this bot. And in our schema, we have actually defined that if an agent loses access to staging, they also automatically lose access to prod. So let's try and deploy checkout to production again. And you can see it needs approval. I've actually not made any change to my permission to prod, but because there's a relationship between staging and prod and I've lost access to staging, I automatically will lose access to prod as well. I'm going to reset permissions and run this again and say, what can I see? And you can see the list of staging environments. I'm going to approve prod and then run what can I see again, and you will see the staging environments as well as the production environments. That's because production autonomy is defined as depending on staging autonomy in the permission model itself. And this is where roles or role-based access control can fall apart. The answer does not depend on one flag. It actually depends on the relationship between different things. And this staging to prod is actually an easy version just for this demo. But in the real world, this can get gnarly very fast. For instance, an on-call engineer can grant her agent prod access during an incident, and that window closes by itself when the incident does. Nobody has to remember to roll it back. Another example. A vendor's agent scoped exactly to one microservice inside your shared monorepo. And the moment this contract ends, every derived permission disappears with the parent. So the million-dollar question is, does this scale past a simple demo? And the answer is yes. The thing you need to know is SpiceDB actually is the open source implementation of something called Google Zanzibar. If you don't know, Google Zanzibar is the internal authorization system that powers all of Google's applications, including Google Sheets, Docs, Maps, YouTube, Photos, and more. In essence, it's built for Google scale. We're talking billions of objects, hundreds of millions of users, and in every part of the world. And Google Zanzibar uses relationship-based access control as well. The mental model is actually very simple. You describe your world once in something that's called a schema. So you describe your environments, your services, users, agents, and the relationships in between them. And then anytime the state of your system changes, you create, update, or delete a new relationship. For instance, if you're delegating access to a new agent, that is a new relationship. If you're revoking access to an agent, that is deleting a relationship. What SpiceDB does is construct complex graphs with these relationships and boils down permission checks to graph reachability problems. In essence, everyone is going to ask the graph the same question. So your deploy bot, your CI, your dashboard, your users, they're all going to ask permission questions to SpiceDB, and SpiceDB will traverse the graph to give you a yes or a no. In essence, it acts as the source of truth for who can do what. These systems were built for high availability, low latency, and scale. So SpiceDB can keep this hot data in cache. And also when your agent needs to check 200 repos at once, there's a bulk call to do that. So it's just one API call. So fine-grained permissions at low latency. The platform engineering and DevOps ecosystem is changing very fast with the rise of AI agents. In the past, we've used traditional authorization models such as role-based access control, but that doesn't just cut it when it comes to AI agents. So to stay ahead of the curve, you have to think about having fine-grained permissions that work at scale. If you want to see this demo scale to 1,000 agents, let us know in the comments below and I'll be happy to build that and show you how to do it. Links to the blog post and the repository are in the description, and I will see you in the next one.